Good morning, guys. I am Mamta from BSc Chemistry Honors final year. So, today's topic is fat, oils, and detergents. Introduction. Oils and fats are widely distributed in nature, both in animal and plant kingdoms. In animals, they are present under the skin and in muscles, but in plants, they are mainly found in the seeds. Some important examples of fats are butter, lard, tallow, beef, etc. While groundnut oil, castor oil, olive oil, palm oil, coconut oil, sunflower oil, soybean oil, linseed oil, sesame oil, etc. are important example of vegetable oils. Fats and oils are one of the three major constituents of our food, the other two beings two beings carbohydrates and proteins. In fact, fat and oils serves as energy reservoirs for the animals. In human beings, only a few hundred grams of glycogen can be stored, which can be barely supply the body's energy need for about 12 to 18 hours. In contrast, large amount of fats can be stored, which can supply the body's energy needs for about 8 weeks. Besides this, oils and fats serves as raw materials for a number of industries such as soap, paints, varnishes and vanaspati ghee, etc. Natural fats. The fats obtained from animal sources such as butter, lard, foam, hogs and tallow from sheep, goats, etc. are called natural fats. This name is simply given to different these fats from the fats which are obtained from hydrogenation of oils. Edible and the non-edible oils. Oils such as groundnut oil, sunflower oil, soybean oils, rapeseed or mustard oil, olive oil, sesame oil, which are used for the cooking purpose, are called edible oils. While oils such as cotton seeds oils, linseed oils, castor seeds oil, or mahua oils, which are used in soap, paints, varnishes, and lacquer industries, are called non-edible oils or industrial oils. On the basis of iodine values, olive oils have also been classified as drying, semi-drying, and non-drying oils, as discussed in section 9.7. Industrial oils may include essential oils or mineral oils. Essential oils such as the rose oils, jasmine oils, lavender oils, eucalyptus oils, peppermint oils, etc. are volatile oils isolated from plants. Essential oils may be hydrocarbons, alcohol, aldehydes, ketones, esters, etc. For example, the peppermint oil contains methanol as its chief constituent. Essential oils are mainly used in the perfumes, cosmetics, and the pharmaceutical products. On the other hand, mineral oils is a mixture of saturated and unsaturated hydrocarbons and not ester in triglycerides. They cannot be sponified. They are called oils simply because of their physical appearance. They can non-edible and the mainly used as fuel. Triglycerides composition of oils and fats. As stated above, fats and oils are triesters of glycerols with higher aliphatic monocarboxylic acid. In other words, they are triglycerols and are commonly known as glycerides. Fat and oils may be represented by the general formula triglycerol or triglycerides. Fatty acids. With only a few exceptions, all the monocarboxylic acids isolated from fat and oils are straight chain compounds containing 3 to 18 carbon atoms. Further, with the exception of only carbon 3 and carbon 5 acids, all other acids found in fats and oils contain even number of carbon atoms. The chief saturated fatty acids present in the oils and fats are uric acid and the mysteric acid, palmitic acid, stearic acid. Besides saturated fatty acid, unsaturated fatty acid containing one or more double bonds in cis orientation may also be present in oil and fats. The chief unsaturated fatty acids present in oils and fats are these. Classification of glycerides. The three fatty acids in glycerides may be same or different. Therefore, glycerides are classified as simple or mixed glycerides according as they have the same or different acid residue. For example, glyceryl tripamylate. Glycerides are the further classified into saturated and unsaturated glycerides according as they contain saturated fatty acid residue or unsaturated fatty acid residue. For example, both the simple and mixed and glycerides are found in natural oils and fats. In fact, oils and fats are complex mixture of mixed glycerides along with small amounts of simple glycerides. Chemical difference between the oil and fats. The main difference between the oils and fats is the proportion of saturated and unsaturated glycerides. Triglycerides with higher proportions of saturated acids residue such as palmitic acid, stearic acid and solids at ordinary temperature and are called fats, while those with higher proportions of unsaturated acid residues such as oleic acid, linoleic acid, etc. are liquid at ordinary temperature and are called oils. Melting points of glycerides. As stated above, fatty acids have one or more double bonds having less stable cis stereochemistry. For example, oleic acid has one cis double bond at carbon 9. Linoleic acid has two double bonds at carbon 9 and carbon 12, while linoleic acid has three cis double bond at carbon 9 and carbon 12 and carbon 15 position. This cis double bonds have vital biological importance in the solid state. The molecule of saturated fatty acids fit closely in the crystal lattice due to their zigzag tetrahedral structures one the other, and the cis unsaturated fatty acids have a band at the double bond and hence do not fit closely, thereby leaving their melting points. Chemical properties. Fat oils being triester of glycerol show the reaction of the simple ester in case the glycerides contain unsaturated fatty acids residue. They also show the usual addition and oxidation reactions of alkenes. Same important reaction of fat and oils are given below. Hydrolysis. Fat and oils are readily hydrolyzed by treatment with superheated steam, mineral acids or alkalis at 500 Kelvin temperature and pressure. Hydrolysis by superheated steam or mineral acids gives a mixture of fatty acids and glycerol. However, when the hydrolysis is carried out by alkalis, glycerol and salts of fatty acids are formed. Since the salts of higher fatty acids thus formed are used as soaps, and alkaline hydrolysis is commonly called saponification. In the digestive system of human beings and animals, fat and oils are hydrolyzed to glycerol and fatty acids by a number of enzymes called lipase. Hydrogenation. Oil which contain a higher proportion of unsaturated glycerides add on hydrogen in the presence of finely divided nickel as catalyst to form solid fat. For example, triolane. This process is called hydrogenation or hardening of oils. It is similar to catalytic hydrogenation of alkenes and involves the reduction of double bonds present in unsaturated glycerides to form saturated glycerides. This process is extensively used for the manufacture of Vanspati ghee such as dalda, rath, gagan, etc. from groundnut, peanut, sunflower and other edible oils. Hydrogenation is never carried out to completion, but it is stopped as soon as fat of consistency comparable to ghee is obtained. The completely hydrogenated fat are too hard to be useful as kitchen shortenings. The main advantage of hydrogenation is that compared to oils, fats, hydrogenated oils have better storage qualities and do not become rancid easily. Hydrogenolysis. Conversion to alcohols, fat and oils on treatment with hydrogen at higher temperature and pressure and in presence of copper chromatite as catalysts undergo reductive cleavage to form glycerol and long chain aliphatic alcohol, for example, tristyrene. This splitting of fat and oils of to glycerol and higher long chain alcohol by hydrogen is called hydrogenolysis. The long chain alcohol thus produced are used for the manufacture of synthetic detergents. Trans-esterification: fat and oils can be converted into simple ester of carboxylic acid such as methyl, ethyl ester, etc. By trans-esterification, it involves the treatment of a fat or an oil with the large excess of stable alcohol in the presence of acidic or basic catalyst, for example, glycerol. The process of trans-esterification is quite useful for the large-scale preparation of a long-chain fatty acids and long-chain primary alcohols of high purity. For this purpose, the mixture of methyl esters obtained by trans-esterification is subjected to fractional distillation to separate the individual ester. These, upon hydrolysis, yield fatty acids of high purity. Alternatively, the individual methyl ester are reduced to the get long chain primary alcohols. Addition of halogens. Like alkenes, unsaturated glycerides add halogen across the double bond to form addition products. The addition of iodine is usually carried out by treating the fat or the oil with iodine in the presence of mercury chloride as a catalyst. Since the amount of iodine used is proportional to the number of double bonds present, therefore this reaction is used for determination of extent of unsaturation in a given fat or the oil. Rancidity: when fat and oils are exposed to warm air and moisture for a long time, they develop a disagreeable smell and taste. This process is called rancidity and involves the hydrolysis of ester to produce fatty acids and oxidation at double bonds to form short chain acid and aldehydes. These short chain acids and aldehydes are volatile and have offensive smell. Therefore, they impart unpleasant odors to oils and fats. Rancidity is of following two types. Hydrolytic rancidity: this type of rancidity is caused by the liberation of lower fatty acids by hydrolysis of triglycerides. For example, when the butter is exposed to warm air and moisture, the hydrolysis of the glycerides in the butter yields butyric acids and the other volatile acids with unpleasant odor. This process of hydrolysis is catalyzed by enzymes which are provided by the microorganisms present in air. This type of hydrolytic rancidity can, however, be checked by keeping the butter covered in the refrigerator. Oxidative rancidity: this is type of rancidity is caused by oxidation of the unsaturated triglycerides by air to form short chain acids and aldehydes having unpleasant smell. It is believed that first, the ester linkages are hydrolyzed to yield unsaturated acids which undergo oxidation at the site of double bonds to produce short chain acids and aldehydes, for example, oleic acid. Oxidative rancidity can be prevented by addition of certain chemicals called antioxidants to antioxidants which occurs in the natural fats are vitamin C and vitamin E. Analysis of fat and oils. Fat and oils are extensively used in the number of industries, therefore it is essential to check the quality of a given fat or an oil. This involves the determination of physical constants such as melting point, specific gravity, refractive index, etc. The chemical constants such as acid value, iodine value, saponification value, Richard Messel value, etc. Some important chemicals constants are described below. Acid value: it is defined as the number of milligrams of potassium hydroxide required to neutralize the free fatty acids present in the 1 gram of fat and or an oil. The acid value is determined by dissolving a known weight of given fat or oil in the pure neutral alcohol and the titrating against standard KOH solution using phenolphthalein as an indicator. The acid value is a measure of free acids present in a given fat or oil. A high acid value indicates that the given sample of the fat or oils is quite old as the becomes rancid. Saponification value, it is defined as the number of milligrams of potassium hydroxide required to completely saponify 1 gram of the fat or oils. In other words, it represents the amount of potassium hydroxide in milligrams required to neutralize the fatty acids formed as a result of complete hydrolysis of 1 gram of the fat or oils. Saponification value is determined by refluxing a weighed quantity of a fat or oil with the a known excess of standard alcoholic potassium hydroxide solution and then titrating the unreacted alkali against a standard acids. For example, saponification values tri triurate and triplemenitine can be determined as follows. For the equations, from the equation 1 mole of fat is equal to 3 mole of KOH. Saponification value is 208. Thus, the saponification value gives an idea about the molecular weight of the fat or the oil. Obviously, smaller the saponification value, higher is the molecular weight. For example, the triplemetine molecular weight is 806 has the saponification value of 208, whereas triurate with molecular weight 638 has a saponification value of 263. The saponification value also indicates the length of carbon chain of the acid moiety present in the oil and fat. The higher the saponification value, greater is the percentage of short chain fatty acids in glycerides of a fat or oil. Butter with the short chain fatty acids has saponification value between 210 to 230, whereas soybean oil has saponification values between 189 to 195. Saponification value is used to determine the adulteration of fat or oil with the some other oil and fat with lower or higher saponification value or even by unsaponifiable matter. Iodine value, it is defined as the number of grams of iodine that will combine with the 100 gram of fat or oils. Iodine value may be determined by any of the following two methods. Hubble's methods. In this method, a solution of a known weight or fat or oils in CCl4 is allowed to react with a known excess of standard solution of iodine in ethanol in presence of mercury chloride as catalyst. The unreacted iodine is then determined by titrating it against standard sodium thiosulfate solution using starch as indicator. For example, the iodine value of triolane may be calculated as follows. Iodine value of triolane is 86. With method. In this method, a solution of more reactive iodine monochloride in gallic acetic acid is used in place of iodine and mercury chloride. A known weight of the oil and fat is dissolved in CHCl3, which is solution is then added. ICl adds across the double bonds. The ICl left unused is then treated with Ki solution to liberate an equivalent amount of iodine. The liberate iodine is then titrated against standard hypo solution using starch as indicator. The amount of ICl that has added across the double bond is then determined using the following relation, where V1 is the volume of hypo used to blank titration, V2 is the volume of hypo used for unreacted ICl, N is the normality of hypo solution, and W is the weight. Iodine value is a measure of extent unsaturation present in the oil and fat. Higher the iodine value, more saturated is the oil and fat. For example, iodine value of linseed oil is 172, 185, tung oil to 163 to 171, soybean oil 127 to 138, sunflower 140 to 156, olive oil 80 to 100. Richard Maswell value, it is defined as the number of milliliters of zero point 0.1 KOH required to neutralize the steam volatile fatty acids obtained by complete hydrolysis of 5 gram of fat or oils. To determine the RM value, a known weight of the fat and oils is completely saponified with the alkali which contains the volatile acids such as the titrated against the zero point 0.1 normal KOH solution. RM value is measure of the volatile fatty acids present in it is highly useful for testing the purity of butter desi ghee which contains a relatively high proportion of glycerides of butyric acid, butyric and the other steam volatile residue. The RM value of adulterated butter is always lower than the pure value. Industrial oil or vegetable origin drying oils. Certain oils such as the linseed oil, tung oil, perilla oil, etc., when exposed to air in the thin layers, form hard and the tough water insoluble solids. This process is known as drying. Such as oils are called drying oils. Oils like olive oils, groundnut oils, etc., which do not dry on exposures to air are called non-drying oils, and those which are dry slowly, such as cottonseed oil, are called semi-drying oils. Chemically drying oils contain a high percentage of unsaturated glycerides as shown by their iodine values. On the other hand, non-drying oils have low iodine value while semi-drying oils have intermediate iodine value. For example, drying oils have iodine value above 150, non-drying oils have iodine value less than 100, while semi-drying oils have intermediate iodine value. Unsaturated glycerides contain linoleic acids, and linoleic acid adds the unsaturated fatty acids residue. These acids contain 2 and 3 isolated double bonds respectively. In general, drying oils containing unsaturated glycerides with conjugated double bonds dry more rapidly than those containing isolated double bonds. Drying oils are used as the medium for paints, varnishes, and the ligatures. In fact, paints and the suspensions of some pigments or the organic color matter in linseed oil to which some tryptophan oils has been added as a thinner. When these paints are applied on any wooden or iron surface in the thin layers, they quickly dry up to the from the tough organic film which protects the surface being painted. Mechanism. The actual process of drying does not simply involve removal of moisture or evaporation of solvents but involves complex changes. It is believed that the reactive allylic hydrogen present in the unsaturated glycerides are first attacked by the hydrogen to form hydroperoxy compounds, which then combine with the allylic hydrogen of the other glycerides molecules, forming peroxide bridges. The monomer molecules thus obtained subsequently undergo polymerization to form a tough network solid. The whole process is sketched below. Soaps. Substances like soaps and the synthetic detergents which concentrate the surface of the solution from the surface films residue, reduce the surface tension of the solution and help in the removing dirt and dust by emulsifying grease are called surface active agents. Surfactants. The molecules of surfactants contains two characteristics of groups, one which contains water soluble and other is soluble. Soaps are the sodium or potassium salt or higher fatty acids such as palmitic acids and the oleic acids. These soaps are generally obtained by the hydrolysis of oils fats with the aqueous alkalis. This process is called saponification of oils and fats. For example, palmitic acids. The fat and oils commonly used for the soap manufacture are tallow, lard, olive oil, linseed oil, mahua oil, rapeseed oil, coconut oil, and palm oil. Soaps containing 12 to 18 chain atoms have good cleansing action. Soap with the 12 carbon atom are comparatively soluble in water, whereas soap containing 18 to 22 carbon atoms are not useful as soaps because of their insolubility in water. Soap sodium are generally hard and hence are called hard soap. Hard soaps these are used for washing the clothes. Potassium soaps on other hands are more expensive and the produce the softer leather and hence the called soft soap. They are used for making shaving cream, shampoo, liquid soap, etc. Transparent soap are prepared by dissolving ordinary soap in the alcohol and removing the insoluble part by filtration. Evaporation of alcohol leaves behind transparent mass. Soap are 100% biodegradable. Microorganisms present in sewage water can completely oxidize soap into CO2. As a result, it does not create any pollution problem. However, soap have two disadvantages. Soap cannot be controlled in hard water since calcium and magnesium ion present in the hard water produce curdy white precipitates of calcium and magnesium soap. Soap cannot be used in acidic solution since acids precipitate the insoluble free fatty acids which adhere to fabrics and block the ability to soap to remove oils and the grease from fabrics. Synthetic detergents these days, in place of soaps, the substances which are being largely used in cleansing agent are synthetic detergents. As the name suggests, they are obtained from the purely synthetic chemicals as compound as compared to soap, which are derived from chemicals which are obtained from natural sources like oil and fats. In fact, synthetic detergents are sodium or potassium salts of given chain long chain alkyl hydrogen sulfates of aryl sulfonic acids. Unlike soaps and detergents, cannot also be conventionally used in the hard water. This is due to the reason that calcium and magnesium salts of detergents, like their sodium or potassium salts, are also soluble in water. Hence, synthetic detergents do not form curdy white precipitate with hard water. Further, they can also be used in acidic solution. However, synthetic detergents have disadvantages. Unlike soaps, they are not completely biodegradable and hence cause water pollution. Synthetic detergents are following three types. Anionic detergents are these are all called because large part of their molecules are anions. These are two types. Alkyl sulfates they are obtained from long chain alcoholic by treatment with concentrated H2SO4 followed by neutralization with NaOH. Some important example of these type of detergents are sodium lauric sulfates and the sodium stearyl sulfate. Sodium lauric sulfate is also called sodium dodecyl sulfates and is used in the shampoo and the cosmetic. These sodium alkyl sulfates are 100% biodegradable. These are also effective in slightly acidic solution since they form an alkyl hydrogen sulfate which is a soluble material, whereas soap reacts with acidic solution to form insoluble fatty acids, alkyl benzene sulfonates. These are obtained by the conversion of benzene into long chain alkyl benzene followed by sulfonation and neutralization with NaOH. The most widely used domestic detergents is the sodium parabenzene sulfonate. It is prepared as follows: benzene treated with anhydrous AlCl3. Another important example is sodium 2-deodocyl benzene sulfonate. Alkyl benzene sulfonate in which the phenyl group is either attached to the end of the long alkyl chain or any other secondary position have high biodegradability and hence are called soft detergents, while alkyl benzene sulfonates having branched chain alkyl groups have poor biodegradability and hence are called hard detergents. To differentiate these detergents on the basis of biodegradability, alkyl benzene sulfonates having long straight chain such as sodium para N didoxy benzene sulfonate and sodium dodecyl benzene sulfonate are called less detergents, while those having branched chain are called ABS detergents. An important example of ABS detergent is this. It is prepared by Friedel Craft reaction in the tetramer of propylene with benzene followed by sulfonation and neutralization with alkali. Cationic detergent. These are the quaternary ammonium salts containing one or more long chain alkyl groups. These are also called invert soaps because their surface activity is due to the positive ions or not to a negative ions, as in alkyl hydrogen sulfate detergents being more expensive than the anionic detergents. They find limited use. Besides being good cleansing agent, they possesses germicidal properties and therefore they are widely used as the germicides in hospitals. For example, cetyl trimethyl ammonium chloride. Non-ionic detergents. These are ester of high molecular mass alcohols obtained by reaction between polyethylene glycol and stearic acids. These may also be obtained from long chain alcohols by treatment with excess of ethylene oxides in